Welcome to this tutorial on exploring your local air quality using particle sensors. We hope this video will give you the tools needed to access data and understand your exposure to particle matter in the air so that you can make more informed decisions about your outdoor activities. This video is presented by RTI International and is the first tutorial in a three-part series that teaches how to use both on-ground and satellite data to understand air quality. Thank you to NASA for supporting citizen science and funding this project. Countless particles are suspended in our air at all times. We can estimate the amount by measuring their concentrations in small areas. Some of the particles you will inhale from the air around you include pollen from plants, dust from surfaces, or emissions from motor vehicles and industry. These particles, particularly those around 2.5 micrometers in diameter and smaller, called PM2.5, can cause health problems when their concentration in the air gets too high. Seasonal wildfires and other types of biomass burning occur throughout the world and impact millions of people in various ways. Even when the fire is not near your area, the smoke from a fire can travel hundreds or thousands of miles with a favorable wind. You might smell it in the air, see black particle deposition on the outside of a parked vehicle, or notice reduced outdoor visibility. To understand your risk of exposure to PM2.5, there are many resources online that you can check daily. Some of these are run by government agencies, and others are commercial websites, either weather-related or owned by particle sensor manufacturers. For this project, we've used particle sensors made by PurpleAir. This tutorial will walk you through using data on the PurpleAir website. You'll also need a graphing software such as Microsoft Excel or Google Sheets. To begin our exploration, let's start by downloading data. Use your browser to navigate to PurpleAir.com. If you're not on the map screen, on the top menu bar, select Map. If you like, you can click the location icon in the bottom right corner to center the map on your current location. For the purposes of this tutorial, we have selected a specific time frame and specific locations for which to download data. However, you can do these kinds of searches for any event or sensor that interests you. We'll be looking at Delhi, India, and 2 states in the USA, California and North Carolina, which are the 3 regions in which this project has distributed PurpleAir sensors to citizen scientists. We'll first search for one sensor in California. Click the magnifying glass in the top left corner of the map and search for the sensor named AQMD_NASA_29. If you experience difficulty with finding the sensor, you may try with a different browser. Sometimes you may need to zoom into the particular region for that sensor to show up in the search bar, in this case, the Southern California region. The map should center on its location once you select the sensor from the results list. After clicking on the sensor location, the graph that appears on your screen will display PM2.5 for the last 2 weeks of measurements from this sensor. The events we want to view, however, occurred months ago, so we'll download a period of data earlier than what this graph shows. On the bottom right side of your map, you'll see a small down arrow. This is the download button. Click this button and you'll be redirected to a data download page. This page will list all of the sensors that were displayed in your most recent map view. On this page, first set your date range at the very top of the page. For the USA wildfire events, we will look at August 1st through September 30th of 2020. During these months, there were many wildfires. You can download data in different time averages. Let's download these data in 60-minute averages. You can set this in the box next to the date range. Once the date range and averaging are set, scroll down to find your sensor in the list below. Each sensor unit from PurpleAir houses 2 sensors, A and B. For this tutorial, we'll only download from the A sensor. Click the Download Primary A button for our sensor, AQMD_NASA_29. Your files will download in CSV format. We'll now open them in graphing software. You may find it quickest to open your file directly from your downloads list. However, if your computer does not automatically open your file in a graphing software, we can walk you through the steps to get there. If you're using Microsoft Excel, open a new workbook. Then go to the Data tab and ask your app to get data from text/CSV. Find your downloaded file. Confirm that your app is identifying the data delimiter as comma. Then click Load. Click File and Save As, and choose Excel Workbook from the drop-down option and click Save. If you're using Google Sheets, upload your file to your Google Drive. Click the uploaded file and click Open With and choose Google Sheets. It should open in the correct format. Your spreadsheet contains the dates and times in UTC of each measure in column A. Columns B through D contain the concentrations of PM1, PM2.5, and PM10, all in micrograms per cubic meter, recorded by the sensor. The CF1 is meant for indoor or controlled environment application. As you may have figured out, the numbers 1 and 10 also indicate the particle sizes of 1 micrometer and 10 micrometers. Column E indicates total runtime of the sensor in minutes. Column F contains RSSI, which indicates the Wi-Fi signal strength, and columns G and H contain the measured temperature and humidity, respectively. The final column, column I, is PM2.5_ATM, which is the atmospheric PM2.5 concentration meant to be used for outdoor applications and is the dataset we'll be using in this tutorial to explore the data. Highlight column I, the PM2.5_ATM data, and we'll display those data in a chart. You should have 1,300 to 1,400 lines highlighted or thereabouts. If you're using Microsoft Excel, go to the Insert tab at the top of your app. Click Recommended Charts and select the Plain Line Chart. After your graph is created, make sure that you set the values for your x-axis so you can observe the data over time. Go to the Select Data option at the top. Click Edit in the horizontal category Axis Labels to choose column A for your x-axis. If you're using Google Sheets, first select column I, the PM2.5_ATM data. Then go to the top menu and select Insert, then Chart. The default chart that Sheets will give you for these data is a line chart. You can then select the data range for your x-axis. You can most easily do this by selecting the grid box at the x-axis selection area, then selecting column A. Now that our data are charted, take a moment and notice where you see increases and decreases in PM2.5. Looking at our sensor in California, the low is usually in the low teens and the high is usually around 35 to 40. The large increase shown here corresponds to wildfires that occurred in this region during that time period. It might be good to know the acceptable daily PM2.5 levels in your region. The U.S. Environmental Protection Agency has set the PM2.5 acceptable level at 35 micrograms per cubic meter on a 24-hour or daily average basis in the United States. The Central Pollution Control Board in India has set the PM2.5 acceptable level at 60 micrograms per cubic meter on a 24-hour average basis for India. It's important to remember a few points when comparing against the regulatory standards and the reference air quality monitor data. Note that the data we're looking at is every hour, or hourly average, while the regional acceptable levels are on a daily average. In addition, these low-cost sensors have inherent bias in their measurements, even though they may correlate well with a reference monitor data. This implies that the sensor data usually track the reference measurements very closely and is representative on a relative basis. However, one needs to use and interpret the data with caution if you were to use it on an absolute basis without any data correction. Note that this tutorial is using uncorrected data for demonstration purposes. Unfortunately, for some of our sensors, higher than acceptable PM2.5 levels occur regularly. Let's look at some specific days of air quality concern from fire events. For NASA_AQCS_171, there was a peak visible on November 9th. On this date, our sensor experienced much higher than normal PM2.5, almost 1,000 micrograms per cubic meter on an uncorrected basis. If this sensor was located near you, an important question to ask would be, does this spike in PM match my experiences of that day? You could also compare the data from your sensor to the readings of the nearest regulatory air quality monitor. To find these data, a useful resource is openaq.org. What else could you do while looking at historic PurpleAir data? Download a full year of data for a sensor and calculate the average. See how this compares to annual air quality standards in the region. If a fire event had not happened, how might the annual average have changed for your region? This can give you an indication of how impactful this specific event was on your whole year. If the sensor is near a roadway, you may want to look at the highs and lows through a single work week. What are the differences in PM 2.5 because of rush hour? If you'd like to download data from our other regions of sensor deployment, try these as examples. To observe smoke passing over from a wildfire in North Carolina, download data for the sensor NASA_AQCS_79 for the date range of August 1, 2020 to September 30, 2020. In Delhi, India, you can observe crop residue burning fire effects by searching the sensor named NASA_AQCS_171. Try downloading these data in the range of November 1, 2020 through December 31, 2020. We hope this tutorial has helped you understand how to access and interpret your on-ground air quality data. In the next tutorial of this series, we'll look at a wildfire event from a satellite perspective. Thank you for your interest and your contributions to citizen science.